What's up everyone, myself Aditi, and today I'm back with LeetCode's another daily challenge problem. So today in this question, we are asked to find maximum score of a good subarray. Okay, let's see the overview of the question. You are given an array of integers nums which is 0 indexed. You are also given an integer k, and they say that the score of a subarray starting from I up to j is defined as minimum of elements or numbers starting from index I up to index j multiplied by j minus I plus 1. Okay, they say that a good subarray is a subarray where I is less than equal to k and j is greater than equal to k. So basically in the end we are required to return the maximum possible score of a good subarray. Okay, so basically the problem overview says we are given an array of numbers and a special position, that is k, within that array, and we want to find a specific subarray that maximizes a certain score. Okay, so basically the goal is to find a subarray which is centered at k that maximizes a certain score. So what should be the approach to solve this problem? Let us understand with the help of this example given. Okay, so basically the example is, first of all, we are given an array of integer array nums, which includes the elements 1, 4, 3, 7, 4, 5, and you are given an integer k equal to 3. Fine. So in this question, you can clearly see that k is 3, and what's the approach to solve this problem? So in this particular problem, what are we planning to do? We are, as you can clearly see, since we are given an array and we need to find a special subarray that gives us the highest score, so it has to be, the approach involves that the subarray is centered around a special position k. Okay, so I decided to use an approach called expanding from center, and it just involves starting from k, okay, and expanding both left and right to find the boundaries of the subarray. So initially what I am doing, I am just initializing my left and my right as the k itself, and then I'll expand my subarray in order to find the highest score. Okay, so the reason I chose this approach, it is because it allows us to consider all possible subarrays centered at k efficiently. Okay, by expanding both ways, we can capture the maximum range that contributes to that score. Fine. So what I have done in this particular example, and I'll be doing the same to solve the question as well. So I'll first initialize some variables. One is left, another is right, and I'm just assigning them the values of k itself. Okay, and so basically let me show you the pseudocode here. I'm initializing left and right variable are equal to k, and then I'm initializing my minimum height is equal to nums of k. Okay, so basically as I have clearly mentioned here, that the good score is in the question, you can particularly see that in place of this nums I, they have given minimum of numbers starting from index I up to j. Okay, so when I have already initialized the values of left and right, that is I and j. Okay, when I have already initialized the values of I and j as k, then it's so obvious that I'll be, at the kth index, and that will be the minimum of it, because it's so obvious when your left and right pointers are exactly pointing to the same number, then the minimum of both of those will obviously the same number. Okay, and then that's the formula. So what's my pseudocode? I'm initializing both left and right to k, and then I'm initializing my minimum height equal to nums of k. Okay, the minimum of all the numbers, when both are pointing to k, then it will be equal to nums of k. Okay, and then what will be the maximum score? Maximum score here implies the good score only, so it will be equal to minimum height. So just to showcase why it is equal to minimum height, I have already solved here. You can clearly see the formula to calculate the max score or the good score was minimum of numbers from index I up to j multiplied by j minus I plus 1. Okay, so nums of k will be there. Fine. And then when you can clearly say left is equal to right is equal to k, that is j is right and I is left. Okay, they are both equal to k. So I have written k minus k plus 1. Basically k cancels another k, and then you are left with another 1. Okay, so basically nums k into 1 will only give you nums of k. So this is some kind of initialization or pseudocode that I will be using. So basically this is the whole approach to solve the particular problem. So fine. So this approach has a time complexity of big O of n. Okay, the just a second. Okay, so basically the time complexity is big O of n, and why it is big O of n? Because it involves traversing the array once only, where n is the length. Okay, and the space complexity is big O of 1, as we are using a constant amount of extra space. Okay, I have also considered scenarios where k is at the boundaries. Okay, k can k. Okay, so yeah, k can be here as well. K can be at 0, k can be at 5. Okay, so I've already considered those cases when k is at boundaries. So we'll have to handle expanding left or right accordingly. Okay, our potential challenge could be handling cases where elements around k are very large or very small, which could affect the score calculation. Okay, so to summarize, we start at k, expand both left and right. Each step we update minimum height. Okay, we will update the minimum height because it's so obvious when k is at 3, so it will be nums of k. But when we are expanding, when we are moving towards left, when we are moving towards right, so we will have to keep updating the minimum height according to the numbers present. So we'll update the minimum height and we'll keep track of the maximum score so far. Okay, so yeah, let's start our implementation. First of all, let's initialize the length of the array as n, which is nums dot length. Now let's initialize our two pointers or variables, you can say, left and right, which is equal to k, and right also at k. Okay, now let's initialize our minimum height, which will be equal to minimum of all of these numbers. So when left and right both are equal to k, our minimum height will be nothing but nums of k only. Okay, because there will be no two different values to be compared. Okay, now let's initialize our max score, which will be equal to min height only. Why? Because maximum score has the formula, that is minimum of nums of I into minimum of nums I up to nums of j, which is multiplied by j minus I plus 1. Okay, so when you can clearly see that minimum of all of these numbers is nums of k only, and then when we have to multiply this part, so when j equal to k, I is also equal to k, so they'll cancel out each other, that is left and right. Left is I, right is j. Okay, so they'll cancel out and then you'll be left with only 1, and then when you'll multiply nums of k into 1, you will simply get nums of k only, that will be equal to minimum of height only. Okay, so maximum score initially will be min height. Fine, so let's start our loop. Okay, we are basically expanding it from our center position, which is at k. Okay, so let's check while left is not at index 0, okay, while it is greater than 0, or right is not at the last index. Okay, so let's check here if left is greater than 0 and right is equal to n minus 1, okay, or nums of left minus 1 is greater than nums of right plus 1. What does that mean? That simply means when you are expanding, what does that mean? You have both the pointers initialized at k. Okay, so since you clearly know I has to be less than equal to k, so it can only move towards the left, and right can be greater than equal to k, that is j can be greater than equal to k. That simply means it can only move towards the right and not left. Okay, so when it's clearly given that when you move your left pointer 1 towards the left, and you see that the value which is okay at k minus 1th index is greater than this, what does that mean? That simply means you will decrement your left pointer. Why? Because you cannot take the greater value, okay, because you want the minimum of it, so you will keep moving the left pointer. Okay, now so let's just let's move our left pointer towards the left. Else if it is not greater than the value which is at right plus 1th index, then we will move the right index towards the right. Okay, then what are we going to do? After expanding from center, let's update our height and score. Okay, so here min height will become, after we have multiple values to compare, it will become max.min of our min height, comma, we will take minimum here of nums of left. Okay, we are going to check it both ways. We'll first check it towards the left, then we'll check it the right value, that is towards the right side, okay, after kth index. So yeah, we'll check it and we'll just take the minimum of minimum height and the value which is minimum out of these two. Okay, so we'll get this. So basically we are keeping track of our minimum height and we are also initializing our score. Okay, this is nothing but the current score, you can say. It will be equal to simply min height into right minus left plus 1. Okay, as given in the formula, that is given in the question, which is j minus I plus 1, it will be simply right minus left plus 1. Okay, and then in the end, what are you going to return? You are just going to return max score. Before that, what will be max score? Max score will be equal to simply max.max of, we are going to take the maximum of what? Max score and our current score. Okay, that is score. If the score or the current score is maximum or it is greater than the max score that we initialized in the beginning, then we'll just update it, and then in the end, we will return our max score. Okay, so let's run the code. Okay, so there is, okay, it has to be equal to, okay, so the mistake is here in the while loop, the right pointer should be less than the length. Okay, it should not be at the last index. Okay, so the code is accepted. Let's submit it. Thank you for watching, guys. Please stay tuned.